afternoon. We are team number 4. We are composed by Andrea Hernandez, Andrea Cobian, Linda Meneses, and Mariana Soto.
And this is practice number 3, hardness test. The objectives are know and use some of the laboratory instruments which can determine the hardness and penetration on metallic materials.
And realize the procedures for the hardness test, Rockwell, Vickers, and Brinell.
Understand the function of the durometers of Brinell, Rockwell, and Vickers.
My name is Linda and I will talk about the experimental procedure. First, it is important to take notes of the material that we are using and to check the dimensions of the specimens that we used. Second, we prepared the durometer and we did 2 measurements for each material. First, we did the probe in the Brinell machine.
We're gonna put the sample in the machine at the middle. And then we're gonna close it till it touches. And then we're gonna put the pressure this. Then we're gonna pull this. And we're gonna wait 15 seconds.
And after we take the sample, we put it into a little microscope where we checked the diameter of the hole, and by this way we took the hardness of Brinell at the end of the practice. Then we changed to the Vickers machine.
Yeah.
Well, this is the Vickers machine, and here is the sample. And first, what we need to do is put the sample here, and with this, I don't know, this thing here, with this piece, we close it till it has the sample there, and then this is the length. And here we could see the piece without the figure. Then we need to change this so we can make the silly dough. And then we need to make the...
It's gonna make a little hole in the piece, so we just have to press the bottom.
And it's gonna get down. It's gonna make a little hole.
And now we're just gonna change this.
And here we will see
we have to align the lines to the figure, so then we have to measure the thing and just write the number.
Okay, the last probe we did was in the Rockwell machine. This machine is not very complicated because it already gives you the data we need to take, like the force we use and the measurements we need. We just put the sample between the thing that's going to make the hole and the base. We put the sample between there. And then we close it till it gets to the thing that's going to penetrate. And then this makes a little hole in the material. And the machine by its own gives us the force we needed. And data I already said. After we took the results, we investigated about the hardness of the materials, and we compare it with the hardness we obtained in the laboratory, and then with the results we calculated the theoretical hardness, and with that we compared it with the hardness we investigated.
What we can recommend is to know how every machine works before using it, and not only know about it but understand the procedure by doing this. Because if we don't understand, the result will be wrong and it will change our results.
The hardness test is used as a tool for the selection of materials and its quality control, and also to evaluate the efficiency of a thermal treatment, to evaluate the resistance of the wear of a material, and to know the machinability of a material.
The rub-bulk limitations are: the possibility of errors is higher owing to the shifting of the sample under the test cycle. And another limitation is the test should not be performed closer to the edge of the material. For the Brinell test, the limitations are that many materials are really hard and they may deform the 10 millimeters ball. The impression of the ball is sometimes considered a deformation of the material, so that's why it's not often used. For the Vickers test, a limitation is that the Vickers method is due to the low speed of the operation, as the measurement of the indentation has to be made optically, and the test area must be carefully prepared and polished, so it is not recommended for testing in production lines. The Brinell test consists of indenting a load to the surface, and that load can be defined by the properties of the material. For softer materials, we use a 500 kilogram pressure to avoid excessive indentation, and it's usually applied to 10 to 15 seconds. No, because hardness is not a fundamental quality.
The sample has to have a metallographic finish so that the extremes of the diagonals can be defined clearly and also can be measured.
In this practice, I learned that it's important to keep the sample center in the test Brinell, because we are exerting pressure and force, and we can break our sample and obtain wrong results.
In this practice, I learned to have precision, especially at the Vickers hardness test, because it can alter the whole result just by putting the lines a little bit open.
I learned that the theoretical hardness of the aluminum should be lower than the